All right, everyone, here's an example from the section 4.1 homework. It says, suppose the true proportion of voters. True proportion means pi. All right, that's pi. The true proportion of voters in a county who support a new fire district is 0.6. So what that tells me is pi equals 0.60. If we consider that we have a distribution of sample statistics for that proportion, and we have a sample size of 175, that's n equals 175. So they didn't give me a p hat, they didn't give me a number of success, they just gave me pi and n. What is the mean of this distribution using the theory-based approach? So I pulled this from one of those pages that I created for you all. So in order to use a theory-based approach doesn't mean that we always use the app. It means that we can do it by hand or with the applet. All right, this problem doesn't give me enough hand information to do it in the applet. So I need to have 10 successes, 10 failures. Well, we've got a pretty big sample size here of 175. The center of that distribution is going to be at whatever my pi value is. So in this case, pi equals 0.6. To calculate, so that's 0.6. It doesn't come close to the pi value. It's equal to the pi value. So the mean of the distribution is pi equals 0.6. The standard error of the distribution is the standard deviation of the distribution. That's this. Standard error is the standard deviation of the distribution. For a theory-based approach, because I have categorical data, I'm using this formula here. Square root of pi times 1 minus pi over n. So I plug that in. My standard error is equal to 0.6 times 1 minus 0.6 divided by n, 175. Here is my S. It wants it to 2 decimal places. So we've got 1 decimal place, 0.037, which rounds to 0.040. Well, 0.04. So that's 0.04. That's one standard error. So now it says, what if we use the 2 standard deviation method to make a decision about where our cutoff is for usual and unexpected? We want the low and the high values. So essentially we're saying that we have a curve like this. The center is at 0.6. And if I do 2 standard deviations, my standard deviation is 0.04, I'm going to say plus 0.04 plus 0.04. And then if I go the other way, minus 0.04 minus 0.04. Or another way to say that is 2 times 1 standard deviation is here. Okay, essentially that's 0.08. If I take the center, 0.6 plus 2 standard deviations, I get 0.68. And if I go this way, subtract 0.08, I get 0.42. So that says it would be unusual if I had a statistic that was lower than 0.42. And it would be unusual if I had a statistic that was higher than 0.68, 2 standard deviations. So let's say I have an observed statistic of 0.53. That falls in here somewhere. So it's in the usual range. If it's in the usual range, it is plausible that the true proportion of voters is actually equal to 0.6.